Hey everyone, Michael Unger here with another edition of Ask an Astronomer. Thank you all so much for joining us and sticking through a few minor technical glitches, but hopefully you can see in the background, maybe it's all worth it because we have brand new wallpaper for our offices. And yes, don't let your eyes deceive you. This is not a Zoom virtual background. These are actual backgrounds to make us look very cosmic in the universe. That is me, Michael Unger, the program coordinator, but also our astronomer, Marley. How's it going, Marley?
It's good. Shout out to Andy who installed them, the new wallpapers. Thank you. They look great.
Yes, and welcome back from vacation, Marley. You
Thank you.
were away for some pretty big news that happened in the universe. Not sure if you've heard of this little telescope called JWST. Finally gave us some new images.
Finally, yeah, no, I was on vacation when they came down. I had planned to go on vacation before they decided that would be the day, but I still tuned in with my grandparents,
Mhm.
Jack and Joan, and my mom, and we watched it live, which was very fun. I liked it. Too bad the CSA dropped out when it was their turn, but I'm glad that you had someone on the show while I was gone to discuss about the images that the CSA was able to get.
Yes, Natalie Willette, who was supposed to have for a big moment with CSA, was able to join us for last week's Ask an Astronomer. But before we dive into this week's news, Marley, I mean, like, just give us a quick feelings, emotions of what you felt seeing those first images from JWST come down.
I mean, I was pretty excited. They were really good images. I particularly enjoyed Stefan's quintet. That is one of my favorite clusters. So it was great to see it, particularly the AGN action that's happening in the upper right hand galaxy on the right hand side there. I think it was the Miri image of that cluster was very, very cool, very awesome to see. And of course, the deep field. Gotta love a
Right.
deep field complete with some gravitational lensing and mirrored images of galaxies and the oldest galaxy ever imaged, like so much from that image. So it was a very great way to start the morning, I would say, on July 12th.
Yeah, what I found interesting, just from those images, is how my friends, people that are not in the science community, how they're reacting to this, because this certainly was a pretty big deal. Starting from the president of the United States, jumping in, getting his moment in the sun to shine, revealing the first image, but obviously, the world at large was finally able to focus on some really fun news in the world. There's not a whole lot of fun news to talk about, but this was something that did kind of bring people together. Lots of people were talking about it, which is good for us in this industry. What about for you? Like, how have the people around in your life reacted to do the JWST first images?
Well, I watched it with my grandparents and my mom, and they were pretty excited about it as well. I think just seeing something and trying to explain to them how far away these objects actually are and how we were able to image it, and also just the detail that we are seeing. Like I remember when the deep field image came up, and explaining to the people I was with that, oh no, those aren't stars. Like those are actually all galaxies, which all have their own stars.
Right.
Just like the scale of what we were looking at is kind of what people that I've spoken to have kind of focused on the most of is just like how large, and even like the Carina Nebula image, like with the gorgeous blue and the orange, and even those are assigned colors, just like the amount of detail, like being able to see these tiny stars forming. They're not tiny, they're huge, they're stars, they're pretty big, but they just look like tiny little pinpricks of light. But knowing that each star that forms typically has at least one planet, we assume. So just the scale of everything we were looking at was pretty mind blowing, I think, for everyone.
Certainly mind-blowing for everyone here at the Space Center. We've been talking about the images a lot. If you're out there watching and have some favorite images, drop them into the chat, what some of your favorite images are. Also, welcome to all of you if you're watching on Telesoptic. If you ever want to join with us live, we are here every second Thursday for Ask an Astronomer. So Marley, let's dive into this week's news story. So we'll put aside JVST for now. I'm sure we'll have plenty to talk about over the next several years. But let's go back and look at a few different missions and a few different places in our solar system. So let's start off first with Perseverance and Mars, our favorite little rover on our red planet.
Yeah, I decided this week enough about the telescope. Okay, I've only been talking about it since December. We're gonna talk about something else. So, interesting with Perseverance is that it is now looking for landing sites. So this feeds into the sample return mission. So all of those samples that Perseverance is taking, those rock samples, are being stored in its belly. And the idea is to one day get them back on Earth. And so, not necessarily with people. Instead, we are going to be sending robots to go collect these samples, bring them back, and send them back on their way to Earth. So, this is a panorama that Perseverance took for a proposed landing site for what is being termed the Mars Sample Return Lander. So, it would have to land somewhere relatively flat to be able to have a stable landing. And so, Perseverance has been scouting out these areas for it. As well as being a lander, the lander would collect the rock and the sediment samples that Perseverance would have collected thus far. And it would also serve as a launch platform for the Mars Ascent Vehicle, which is the rocket that would launch from the surface of Mars and reconnect with an orbiter and get those samples back on their way to Earth. And so they want a very specific area that's kind of, I wonder how easy it's going to be to find on Mars. They want an area that lacks rocks and sand dunes, which seems to be all that Mars is sometimes, and also lacks steep terrain. So really this very flat, more so pebbled area as opposed to boulders or those large sand dunes. And an update with the sample return mission is when it first started coming out, it was being discussed of being a mission that contained two rovers, fetch rover and lander. And now they've decided to scrap those two and instead are going with two helicopters based on how Ingenuity was built to go and collect the samples instead, which I thought was a very fun update, scrapping a rover for a helicopter. Of course, we know how well Ingenuity has done, really blew everything out of the water. So they've finished the system requirements review, NASA and the European Space Agency, members of those two space agencies, and the conceptual design phase is almost finished. And once that is finished, they're able to begin what's called the preliminary design phase. And that's expected to last about a year. And that should begin in about October. And what that does is when they start completing technology development and beginning and some engineering prototypes of these major mission components. So prototypes of these two helicopters, these two rotocopters that will be developed, and also starting to develop basic engineering of like the lander and the Mars lander and stuff like that. So lots of little pieces coming together, and they're aiming, if everything goes well and according to their schedules, to have the samples returned to Earth in 2033. So not too far away, a little over a decade from now.
This is really exciting, and I think this was probably in the back of their minds that perhaps they would use a copter instead of a recovery rover. It makes more sense, just logistically. I'm sure it's a lot cheaper than building another rover. But what were some of the other considerations, in going with this? Is it just purely cost and those reasons I laid out?
It was partly cost and partly the fact that the rover would have to have its own lander, the fetch rover. So you'd actually be sending two landers, a lander that has the Mars Ascent Vehicle and a lander that has the new rover. So there'd be two landers you'd be sending. In this case, it seems as though the Mars Ascent Vehicle and the copters can just be packaged in the one lander, and you wouldn't have to have all these multiple components, just, reducing points of failure and all that. It also probably is cheaper. As we know, Ingenuity is quite small. It's only the size of a tissue box. So it fit in the belly of Perseverance. So it doesn't necessarily have to be as big with as many working parts as a rover.
Okay, so that's really exciting. Looking forward to that in, it's 11 years to get those samples back.
Listen, we waited forever for Webb. We can wait a bit longer for Martian samples. We'll be fine.
And plus, Marley, you are young at this game. Like we can almost guarantee that you will be talking about these samples at some point in 2033. With the way that you're going with your space career, I can almost assure it. So this is something I think for you. That is going to be like your life story. Is like Perseverance. You started working here when it landed on Mars. You're still going to be talking about Perseverance in 11 years. I think that's really cool to think about.
Yeah, that was like kind of a weird performance review for Michael just now, but thanks, Michael. Yeah, all right, sure. I will probably talk about this in 11 years. Yeah. That'll be interesting. But it kind of all came from this new sample that the rover took. So we're now in a new area on Mars, and we're finding a lot of sedimentary rocks, so rocks that have been layered, because we're actually in like the delta area, the cratered region, the floor, and we've moved from the floor into kind of the delta. So now we're getting these layered rocks, and these sedimentary rocks have fine particles that can be carried by atmosphere or water and deposited in like flat layers, right? If you've ever been to the Badlands in Alberta, you know what I'm talking about, those very, very layered rocks. And these layers become rock over time. And so the first sample they took of the Jezero Delta was July 7th, or Sol 490. And it was very exciting because it's been very difficult for Perseverance to find a good candidate rock to take a sample from, because the first few rocks either fractured way too easily when they were abraded, which is that circular mark on the, looks like kind of like a petri dish. It's just been scratched away. And so some of the rocks actually fractured when they scratched it, which would be bad for a sample, or the surfaces were too rough to place the drill. So they were very excited. The team was very excited when they finally got this rock. And the interesting part is that the inner rock, once revealed on this specific rock being called Skinner Ridge, is it has individual clasts with very clear boundaries. And in my very, very brief geology research, a clast is these other bits of rocks within a rock. So very clear, kind of like pebbles, but it's like other would have been from other rocks that have now formed into this one rock. And you can clearly see the boundaries in the abrasion. And when they took the sample, the abrasions were still there. So this is the sample in the coring tube. And then this is a raw image of the sample. They zoomed in on it in the coring tube, and you can still clearly see these clasts. And clasts are exciting because clastic sedimentary rocks are mostly composed of broken pieces, and the clasts are older, weathered, or eroded rocks. So if there was water present, in which many clasts come from, clastic rocks is a classification that helps in determining where the environment was deposited. So if you look at this type of rock and you can see these little pebbles, these little stones, these little clasts inside of it, that what those are made out of can help tell you what the environment was like when this rock was formed. And so an example that they used was that a river system where grains are being transported by water would go in and form this. So this clast is exciting because it might be another sign that, okay, there definitely was water here. There was running water, at least to be able to create these types of rocks.
And just to be clear, what you're saying, because almost, I think you may even stumbled on a bit. You're saying clastic, that's CLASTIC, which is a very specific form of rock, right?
Yes. So this rock is clastic because it has clasts. It's very weird. Yes. I am not a geologist.
Yes. Well, in etymology speaking, it perhaps has some similarities to the word plastic, but it, of course, is an actual rock, whereas plastic is fake. I don't know if there's any more associations there, but I always like looking at the roots of where these words come from. Can we change them? It's similar to a lot of other words. So I always get tripped up when there's words like plastic. That seems like a lot of other words.
Yes, I have no idea where the word came from. It's just they called it clasts, and I was like, what is a clast? And that Wikipedia page was very confusing. So it's just these little bits that look like they don't belong. Clasts probably came from older rocks upriver and were eroded away and now have formed into this rock layer.
So if we get back to the heart of this clastic rock, a question from Harry is in two parts. What is the purpose of getting these samples, and perhaps specifically this kind of sample? What are the expectations, in finding, what do they hope to find with this sample? And are they going to be looking for other samples?
Right. So the general overview of why Perseverance is collecting samples in the first place is because in the Jezero crater, where Perseverance is where different scientists predict it's like the best place, that if there were life on Mars, it's the best place where it would have been. The Jezero crater is like right in the middle and overrides a ancient river delta. So looking at the geology of Mars, now that all the water's evaporated away, you can see a clear geologic structure that looks like a river delta, very much like the Fraser River Delta, where you have this fan kind of swept out through the rocks. And so if there was life on Mars, this location is the best bet, with the running water providing a constant source of nutrients and oxygenation of the water and stuff. And so that's where they're looking for. And so what happens when in the search for life, if there was life there, once it died or was wiped out, it could have become similar to fossilized, right? Traces of it would remain in these layers of rocks. And the layering is important as well because that gives us kind of like a time capsule, right? Each layer is from a different time period. And if there's a drastic change, that would be reflected in the geological record of this layering. And so that's why they're taking samples from this area. The idea that any little traces of single-celled organisms or tiny microbial life would have been quote unquote fossilized in these layers of rocks as they solidified from the grains being swept downriver into rock.
Excellent. This is Perseverance, and of course, Perseverance did also have a companion that we've already talked about, Ingenuity. So what is the current status of that little tiny helicopter?
He's just trying to make it. It's really dust and winter season now on Mars, right? So Mars has entered its Martian winter, and with Martian winter comes much colder temperatures and also a lot more dust. And so with that, Ingenuity's batteries have not been able to charge. It is a solar powered copter. And so not being able to have a full charge means it sometimes resets itself, and also that it's not able to keep itself warm overnight. And so the constant turning on, running commands, and then waiting for the batteries to charge again was too much. And so the team decided to let the rotocopter rest and charge up its batteries as much as it can without, turning on running tasks and then losing charge. So just charge as much as it can. And hopefully come early August, they will be able to resume flights. They expect the dust that's currently in the area to subside later in July. So probably in the next few days or so, and then they'll recheck on the helicopter then. But Ingenuity did do a very, very good job at what it was meant to do, but unfortunately, Martian winter is very cruel for anything solar powered. So it might be time to say goodbye soon.
So in thinking about that, because of every place that we could potentially land a lander or a helicopter, like the moon, like Mars so far, perhaps any other places we go to, is always going to be dealing with this hot and cold situation, and potentially dealing with long nights where it does get really cold. So what do they do on these machines to ensure that if they do go through like some unexpected or perhaps expected in this case seasons on Mars, to ensure that Ingenuity is still warm enough to not completely freeze over so that it can sort of come back to life at some point when it's warmer weather?
So with Ingenuity, the difference between Ingenuity and other ones like say Perseverance, which it came with, is the different power source. So Perseverance runs off of nuclear power, which is what generates the electricity on board, and that also keeps it warm. The radiation from that nuclear decay will keep the robotics warm. Ingenuity is solar powered, and additionally, Ingenuity is mostly made out of off-the-shelf parts. So its batteries, its wiring, and stuff are just like bought at, I don't know, like a hardware store. Right. So they're not built to survive, that cold of a temperature. So when they resend, if they're going to send those helicopters for the sample return mission, they would probably be built with materials that would be able to withstand the weathering events on Mars.
Excellent. Okay, so looking forward to Ingenuity coming back online next month. Let's move on to another very cold and hot sometimes destination that humans will be going to soon, not quite yet. And that is the moon. We've got some new science that have come out from the LRO, which is the Lunar Reconnaissance Orbiter.
Yeah, the Lunar Reconnaissance Orbiter has taken these very gorgeous images. This is what's called the Marius Hills Pit. So the moon has these pits, and the best way to describe them is a pit, because it's just like deep down. It's a very deep hole, essentially. And so this is the pit that was imaged by a team. It is 34 meters deep and 65 by 95 meters wide. So it's very, very large. And these pits were first discovered in 2009, and we've been very curious about them ever since because they're not craters. They're huge, deep holes in the surface. So the idea was if we, go to the moon again, could we explore them? Could we use them as shelters? And from the science, the team found that about 16 or more there's probably about 200 or more on the surface, but about 16 of them are probably collapsed lava tubes. So when molten lava flows beneath a field of cooled lava or crust forms over top of a river of lava, you eventually get a long, narrow tunnel, like a very long tube. But if the ceiling of the tube collapses, you now have an opening into this tube, into this kind of tunnel structure. And we see just the opening as a pit. And so we know that the moon has some extreme temperatures. They can get very hot on the daytime side, day lasts very long on the moon, and night gets very cold and lasts just as long as day. And so focusing on a roughly cylindrical depression, one of these pits, about 100 meters deep, a team, I think his last name is Horvath, and his colleagues, he's a postdoctoral, I'm not sure if they're students, postdoctoral researcher. It was looking to see what the temperatures would be inside of these tubes, right? So if we could explore them or whatever, we have to keep that into account. And so using computer modeling to analyze the thermal properties of the rock and the lunar dust and to chart the temperatures over time. So he looked specifically at this one in this picture here. And the little scale is like 100 meters. So it's very, very big. And it is in the Mare Tranquil, I can't pronounce this word. It's the Sea of Tranquility is where it is, where my little laser pointer is. It's located in this region of the moon, so we can see it, not the depression, but where it lives. And he and his team found that the permanently shadowed regions of the pit, so the regions that never get any sun in this pit, only fluctuate a little bit during the day, but they sit at a pretty stable 17 degrees Celsius. So could potentially go under there and see what's up. But it is a very interesting little thing that's come out of Lunar Reconnaissance Orbiter imaging and research.
Wow, it just goes to show like just how treacherous the moon's surface is. Like it's got these really, really deep craters and surprisingly high mountains too. I don't know if you ever saw the movie Ad Astra with Brad Pitt. It was an okay movie, but one of the best scenes in that movie was a moon buggy chase that was happening. And I thought they actually did a good job of showing that, you know, once we do get some sort of systems in place, some outposts, and if these outposts are somewhat distant from each other, they're going to have to be very careful traversing this terrain unless they want to start building some roads, because all of a sudden you're going to have like this big pit just out of the nowhere. That's wild.
Just like this big hole. Like, I don't, it's like, all right. When it was said like we discovered them in 2009, I was like, I was not told. Like, what are you talking about? There's just holes on the surface of the moon. But turns out they're very comfortable 17 degrees Celsius in the permanently shadowed regions. So I'm a fan. Let's go there.
Well, and this, I think, maybe brings up the idea that I have read before, which is maybe building around some of these infrastructures might be good places for the bases, because if it's a good temperature there, maybe that could be a good structure to build a base around, say.
Yeah, and the fact that you can get underground, which would help like shield you a bit from radiation and stuff, given that the moon has no atmosphere really to protect from that solar radiation. Being underground would make that a bit better.
Yes, and that is, of course, there is no space slugs living in these.
The worms from Dune just coming out of nowhere.
I actually just rewatched the mini series from Sci-Fi TV that came out in like 2000.
Yeah.
So bad, but also
it was good for its time.
So enjoyable as well.
Yes. No, the worms from the movie. Well, I was like, whoa, so cool.
And our final story for today, before we end up, is of course how we're going to get to the moon, and that is with Artemis. So what's going on with Artemis?
So we finally have placeholder launch dates. They're not promising that these will be the days, but they're kind of reserving these days for the launch of Artemis 1. All of these dates penned repairs and tweaks from the wet dress rehearsal that happened in June. So that wet dress rehearsal saw that there was a leak on one of the umbilical seals, which is the wires that connect to the rocket that bring in the rocket fuel, the liquid hydrogen, oxygen. There were leaks on those, and that is really bad. So they had to go take that back, fix the seals on the quick disconnects. And so technicians are now testing those newly replaced seals to make sure there are no more leaks. They're also installing flight batteries and the flight dummies, which is Commander Munikin Campos, who is a full male-bodied mannequin, and crewmates Helga and Zohar, which are phantom human torsos. It's just like a human torso. It's kind of creepy. But they will be riding in the Orion capsule, so they can collect data on, the G's and all of the different forces at play and what happens to a human body in there. But we have placeholder launch dates. We have August 29th as the closest one. The launch window would open up at 5:33 a.m. Pacific time, and it'd be a 2-hour window. So it could launch anytime between 5:33 and 7:33 a.m. And then that would be a 42-day long mission, landing or splashing down on October 10th. The second one is September 2nd, a 2-hour launch window, a 39-day long mission. The launch window would open at 9:48 a.m. That should say a.m., not p.m. Pacific time, and go until 11:48 a.m. And of course, the last one is September 5th, which is only a 90-minute launch window, and would give a 42-day long mission again, and that would open at 2:12 p.m. and go until 5:12 p.m. for an hour and a half later, 3:45. And those are our launch windows for the Artemis 1 mission, which hopefully they'll go ahead. They were really pushing for an August launch, and I was like, I don't think you were going to do it, but they're really trying to slide right in there at the end. So good luck to the team.
Yes, looking forward to that, and of course looking forward to potentially when we'll see humans on Artemis, and potentially a Canadian as well. We potentially may even have a Canadian astronaut who's going to visit us this fall. We're working on lots of exciting programs coming up. We've got Perseids meteor shower coming up. We're going to be talking about that in our next edition of Ask an Astronomer a bit. Definitely check our website for some of the events we have going on. We've got a webinar on August 10th that you can join. We'll have an in-person event here on August 11th. If you like to be in the planetarium, get a primer on meteor showers. We'll also have our observatory and some activities that night. And we're also going to be going out to McDonald Park on August 13th. And that is one of the best places in the Lower Mainland to view the Perseid meteor shower, or any astronomical viewing, because it's a dark sky preserve. So it's just a big park where they have been very diligent on turning off all of the lights all around the park, and that's out by Abbotsford. If you are free that night, and of course we've got a whole host of programming they're working on here for the fall. So lots of exciting stuff here at the Space Center, and we will be back in a couple of weeks for another edition of Ask an Astronomer. Marley, thank you so much for this week's information. We will see you in 2 weeks. Bye, everyone.
Bye, everyone.